Here's something that'll blow your mind. Almost everything Hollywood taught you about space is a lie. And I'm not talking about minor details. I mean fundamental, you've believed this your whole life kind of stuff. The worst part? These myths are so convincing that even smart people fall for them. But by the end of this video, you'll never look at space movies the same way again. Let's start with probably the most dramatic one. The explosion that never happens. Picture this. An astronaut's helmet cracks. Sudden decompression. What happens next? If you said they explode, congratulations, you've watched too many movies. Remember that scene in Total Recall where Arnold Schwarzenegger's eyes practically pop out of his skull? Or every sci-fi thriller where someone gets blown out an airlock and instantly turns into confetti? Complete fiction. Your skin is remarkably resilient and strong enough to prevent your body from exploding in space's vacuum. Think about it. Your skin can already handle significant pressure differences every single day. Ever been deep underwater? Your body managed that just fine. The drop from Earth's atmospheric pressure to zero is only about 1 atmosphere of pressure difference, and human tissue can absolutely handle that. But here's where it gets interesting and genuinely unsettling. What actually kills you in space isn't some explosive decompression. You'd remain conscious for about 10 seconds before your brain shuts down from oxygen deprivation. Your blood doesn't boil either because your circulatory system maintains its own pressure. What does happen is something called ebullition, where water in your tissues starts to vaporize, causing painful swelling. But this takes time. You're talking minutes, not seconds. The truly wild part? In 1965, a NASA technician was accidentally exposed to near-vacuum conditions in a test chamber and remained conscious for about 14 seconds. He survived. Think about that. Actual human beings have experienced this and lived to tell the tale. Yet Hollywood keeps showing us bodies exploding like popcorn kernels. So why does this myth persist? Because drama sells. A slow suffocation doesn't make for great cinema. An instant explosion does. And we've all internalized it as fact. Now, you're probably thinking, okay, but at least people freeze instantly in space, right? It's like negative 270 degrees Celsius out there. Wrong again. This one's even more counterintuitive than the explosion myth. In space's vacuum, there's no air to conduct heat away from your body through convection or conduction. You can only lose heat through radiation, which is extremely slow. Here's a mind-bending fact. You would freeze to death faster in water that's only 40 degrees Fahrenheit colder than your body temperature than you would in the vacuum of space. Let me explain why. On Earth, when you're cold, air molecules physically touch your skin and steal your heat through conduction. Water does this even faster. But in space, there are no molecules, no air, nothing to conduct that heat away. You're basically wrapped in the universe's best insulation. Absolutely nothing. Your body generates about 100 watts of heat constantly, roughly the same as an old incandescent light bulb. It would take several hours for your internal body temperature to drop below freezing in space. Of course, you'd be long dead from oxygen deprivation by then, but you definitely wouldn't be an ice sculpture. The movies got this backwards. Space isn't your enemy because it's cold. It's your enemy because there's nothing there. No oxygen, no pressure, no molecules to breathe. The temperature is almost irrelevant when you suffocate in under 2 minutes. The asteroid belt death trap. Remember that iconic scene from The Empire Strikes Back? Han Solo weaving through a dense field of tumbling asteroids, rocks the size of buildings spinning mere meters apart, C-3PO calculating the odds of survival at approximately 3,720 to 1. Yeah, about that. The real asteroid belt is so empty that calling it crowded is like calling the Sahara Desert a beach. The odds of a spacecraft colliding with an asteroid while passing through the belt are estimated at less than 1 in a billion. Think about that number, 1 in a billion. You have better odds of winning the lottery while being struck by lightning. Here's the reality check. If you gathered every single asteroid in the main belt together into one object, you'd create a dwarf planet only 930 miles in diameter that's smaller than Pluto and represents only 3% of the moon's mass. And this tiny amount of material is spread across a region of space so vast, it's almost incomprehensible.
The average distance between asteroids larger than 1 kilometer across is several 100,000 kilometers. That's hundreds of thousands of miles of empty space between each rock. If you were standing on an asteroid and looked up, you wouldn't see a crowded sky full of tumbling boulders. You'd be lucky to spot even one neighbor without a telescope. NASA doesn't spend time calculating asteroid avoidance routes. They actually do the opposite. When plotting spacecraft trajectories through the asteroid belt, engineers will deliberately change flight paths to intercept asteroids for study, because they're so far apart that encountering one requires effort. Every single spacecraft we've sent through the asteroid belt, Pioneer 10 and 11, Voyagers 1 and 2, Galileo, Cassini, New Horizons, and more, passed through without incident. Not one spacecraft has been lost while traversing the asteroid belt. The most dangerous part of space travel isn't navigating asteroid fields, it's getting off Earth in the first place. The twinkling star illusion. Quick question. Why do stars twinkle? If you answered because that's just what stars do, you're in good company and you're also completely wrong. Stars don't actually twinkle at all. The flickering we see has nothing to do with the stars themselves and everything to do with Earth's turbulent atmosphere. Here's what's really happening. Starlight travels through millions or billions of miles of empty space without any problem, perfectly stable, constant, unwavering. Then it hits Earth's atmosphere and suddenly it's bouncing around like a pinball. Our atmosphere is constantly in motion with layers of air at different temperatures and densities all swirling around. When starlight passes through this chaos, it gets bent, refracted, and scattered in constantly changing ways. Viewed from space, stars would not twinkle at all. Astronauts on the International Space Station see stars as steady, unchanging points of light. The romantic twinkle that poets write about? That's just atmospheric turbulence playing tricks on us. This actually matters for astronomy. Professional telescopes struggle with atmospheric distortion, which is why we build them on mountaintops and in deserts, places where the air is thinner and more stable. It's also why space-based telescopes like Hubble can capture such incredibly crisp images. They're not looking through Earth's atmospheric blender.
The dark side deception. The dark side of the moon. It's a phrase embedded in our culture. Pink Floyd made a legendary album about it. We use it as a metaphor for hidden, mysterious things. There's just one tiny issue. There is no dark side of the moon. Both sides of the moon receive equal amounts of sunlight throughout the lunar cycle. What we have is a far side, the side permanently facing away from Earth, but it's not perpetually dark. During what we call a new moon, when the moon is between Earth and the sun, that far side is actually completely illuminated, while the near side sits in shadow. The moon is tidally locked to Earth, meaning it rotates on its axis at the same rate it orbits our planet, which is why the same face always points toward us. This isn't unique to the moon, by the way. Many moons throughout the solar system are tidally locked to their planets. Photos taken by the Soviet Union's Luna 3 spacecraft in 1959 showed the far side fully illuminated by sunlight and revealed it's actually lighter in color than the near side we see from Earth. If anything, the side we always see from Earth is the true dark side in terms of albedo. It's literally darker rock. The persistence of this myth reveals something interesting about human psychology. We're so captivated by mystery and hidden things that we've created darkness where none exists. The dark side of the moon sounds infinitely more compelling than the far side we can't see from Earth because of tidal locking. Marketing wins again. The zero gravity deception. Here's a myth that actually makes scientists facepalm. There's no gravity in space. If this were true, the entire universe would fly apart. Gravity exists everywhere in space. It's the force keeping the moon orbiting Earth, Earth orbiting the sun, and entire galaxies held together. So why do astronauts float on the International Space Station? They're not floating because gravity disappeared. They're in a constant state of free fall around Earth. The ISS is falling toward Earth continuously, but it's moving forward fast enough,
about 28,000 kilometers per hour, that it keeps missing the planet. That's what an orbit is. Falling sideways so fast you keep missing the thing you're falling toward. At the ISS's altitude, Earth's gravity is still about 90% as strong as it is on the surface. Astronauts experience weightlessness not because gravity vanished, but because they, the station, and everything inside it are all falling together at the same rate. It's the same feeling you get in the split second at the top of a roller coaster drop, stretched out for months at a time. This matters because it's fundamental to understanding how space travel works. Satellites stay in orbit because of gravity, spacecraft navigate using gravitational assists from planets. The entire cosmic dance of planets, stars, and galaxies relies on gravity. Without it, there would be no solar systems, no galaxies, no structure to the universe at all. Space isn't a gravity-free zone, it's a gravity-dominated environment where everything is constantly pulling on everything else.
Why these myths matter? You might be wondering why any of this matters. They're just myths about space, right? These myths reveal how easily we accept dramatic falsehoods over boring reality. Hollywood's version of space is more compelling than the truth, so the lies spread while the facts struggle to catch up. We share the myths, we teach them to our kids, and they become common knowledge. When we trade facts for fiction, we trade wonder for shallow spectacle. The universe doesn't need Hollywood's embellishments. Reality is weird enough on its own. Every time you watch a space movie now, you'll notice the mistakes. The explosive decompressions, the color of stars, the impossibly crowded asteroid fields, they're all there waiting to be spotted. And maybe, just maybe, you'll turn to whoever you're watching with and blow their mind with the truth. Because the worst space myths everyone still believes, you don't believe them anymore. The universe thanks you for your attention.